glad you weren't just taking off your...
That would be really unfortunate.
Especially because the video is about to be recording. Okay. Number 3. Assume that 30% of students at a university wear contact lenses. We randomly pick 100 students. What are the mean and standard deviation of the proportion of students in this group who may wear contacts?
I don't think Brooke knows.
Brooke, stop.
Chill out. What are you doing?
Okay.
Norfolk Zoo. I need to get that signed.
Hold on. We did this yesterday. It is 0.30, right?
Yep.
I'm so good. I was laughing and y'all couldn't even beat me.
Flip into the page. But you don't have to flip
Brooke,
to
we
the
weren't
stupid
trying.
page.
Okay.
Standard deviation.
Is the square root. I know 0.30's on the bottom. No, 100's on the bottom.
Of
0.100. 0.1. 100?
0.3 times 0.7 over 100.
There we go, guys. Oh, I need my calculator.
Why is it point? Oh, never mind.
Maybe I should.
I'm not in it to win it today, guys.
I like minute to win it.
Okay, whew. I need to not.
What?
Okay, I trust him.
I don't know.
I got 0.04.
0.0.
I just like a whole
I got 0.046.
I agree with them, even though I didn't do the problem. But I did the first step, so.
No, I multiplied by 100 and then I completely forgot about square root.
Oh, that makes a big difference.
All right, let p hat represent the proportion of students in this sample who wear contacts. What is the appropriate model for the distribution of p hat?
A normal model?
Okay, because we're assuming what?
Because we're assuming.
Less 10%. Less the
Okay.
thing.
So in general, we're assuming that the conditions are met. Okay, so assume conditions are met. So our normal model then N of mean 0.3 and standard deviation 0.046.
Oh!
Melcher, you changed hats.
No, I didn't.
Or well, you added a hat.
Whoa!
His
Mom is home today. She got home early.
Who did?
My mom.
That's
That's
good.
I
exciting.
have that ball.
I want a half
I
day.
wish there was a half day.
Do you know how much better a half day would be?
Right?
I feel so bad. She apparently has the worst class of the 3rd graders.
Who?
There was one guy. We're recording. Never mind.
Tell us later?
Yeah.
Tell us later.
Oh, I also have something.
Okay, I'm intrigued now.
I
Me
also
too,
have
so tell us later.
a fundraising idea that we could possibly do. It's not one.
Tell us later. Stats! 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 I want to get stats done.
Stop.
I want to get stats done so we can talk about fun stuff.
I want to get stats done so I can study history. Then we have like that.
Did you not study yesterday?
What assumptions underlie your model? Are the conditions met, and explain?
What assumptions underlie your model? Okay, that's less than 10% of the college people.
Okay, 10% condition. Okay, because 100 students,
Bigger than 10%.
less than 10% of university students.
How do you know that?
That just would be like in general. Because a university is not, well, we're going to assume that a university does not typically have less than 1,000 students.
Alright, what else are we assuming? We're assuming the NP is less than 10. Greater than 10.
Okay, so success, failure.
Yeah, that thing.
So NP greater than or equal to 10 because 0.3 times 100
Why
is
do you
equal
check
to
marks so
30.
much better? That's not-
I don't really know. I think that one got one of because you can do it where it'll like fix it. I think.
What?
I think you can do it so it'll fix it. Nope, just kidding.
No, that's not it.
No, you're just good at
No.
Never mind.
It doesn't. You're
Okay.
just you. It doesn't even fix it and yours looks good.
So this is 30 that expect to wear contacts. Okay, I'm just gonna label everything in this one, but you don't necessarily have to be this detailed when you actually do yours. But at least you have it when you go to look back.
That's always good. I realized when I was studying last time I need to write everything that I need like steps down because I look at it and I'm like, oh, how did I get that?
And then NQ is 0.7 times 100, which is equal to 70. Would expect to not wear contacts. No wear contacts. Not wear contacts.
I don't know why that just really reminded me of that one.
And what would the last condition be?
Independence, right?
Well, yeah, random, independent, basically the same thing. Random selection. Okay, they randomly picked.
I just drew a pretty check mark. Aw, what a great day.
Bro, you need
And another thing about it, just to note, is that the sample is not too big or too small.
Oh,
How do you
yeah.
know it's too big?
A gazillion people.
I mean, it's kind of just like you just figure out that it's way too big. There's not like a written rule of what's too big.
Because they only
I mean, like within reason. If there's if let's say that there's 10,000 students at your school and you survey 9,950 of them, like that's ridiculous. If the sample would be huge comparatively to the rest of this. You know what I mean?
Makes sense.
All right. What's the probability that more than 1/3 of this sample wear contacts?
Oh! Did we draw the little thingy now? Yay!
Ooh, that was bad.
That's like how mine looks. Don't call it bad, that's what mine looks like.
What?
Oh, I know.
What is the ideal gas law on your cup?
What?
What?
I think you should lend me that mug for our test today.
Did you say why is it on here or what is it?
Why is it on there?
Because it's a math mug.
I don't like it.
It's got all kinds of math equations on it.
Yeah, but I wasn't
E to the I
expecting to
pi
see
plus
that.
1 equals
Can I,
0.
like,
I didn't wanna
always
see
have
that.
like hot chocolate in that, like every
7th
pre-cal.
period. Oh. What?
like for everything, like pre-cal, stats, and
No, why does my normal auto look bad?
chemistry tests, please.
Melcher, don't be mean to
Einstein's
me.
general theory of relativity, Newton's second law, Schrodinger's equation. I haven't seen that since like abstract algebra.
Ugh. Abstract?
Mm-hmm.
Why is it called abstract? I don't like
Because
that.
there's no numbers.
What? So how do you solve the problem?
What?
Exactly.
How does it matter? There's no.
Oh.
Okay, I'm not saying there's never numbers, but there's more letters and words
Should it
than
not?
numbers.
How do you do that? Like, how do you? That makes me.
I guess it is kind of like stats.
I'll,
stats
if I
is
can
fun.
find some of my abstract homework, I'll bring it sometime and let y'all see what my abstract homework looks like.
I can give you some stats that's
Are you, like-
abstract.
A lot of
Nick, you want to cry? That's what it'll do to you.
More than stats?
Yes.
Oh no. I don't
Abstract
see
is
it.
like a senior level math class
Oh no.
in college.
No.
Exactly. Okay. All right, so
The mean is 0.30. The next standard deviation is.
Ew, but
Hold on, my thing is frozen. Okay.
I hate doing this.
0.346. The next one will be.
How could you not do that? in your head?
just FYI, we don't need to do all of those.
I lied.
Okay. If you see this, more than 1/3 of the sample, okay, what calculator function are you thinking of?
I'm thinking of Not normal
It's
CDF.
the one
normal
with the
CDF?
with the.
Is it normal CDF? Like, actually, woo, that's hard. Ah, love me.
Oh, can we go over tests today?
The only reason I knew it
Oh,
was
yes.
normal CDF is because I know I needed that on my test and I didn't.
Okay, normal CDF. For this, you need to find, because we're talking about for the sample, okay, we do need to find the Z because the Z value is what's going to go right here.
The Z score.
Okay?
Z equals.
Okay, now keep in mind, it's X bar, okay, or in this situation, it's technically Y bar because
It's like
that's what
Y
goes in
minus Y hat
No.
over Y, right?
What?
Okay,
Yeah.
so it's the sample standard deviation, okay, like what it wants, okay, which is 1/3, which would be 0.33, minus what the actual mean is,
And that's
30% to
Zero,
0.3.
over the standard deviation, which is
0.046.
0.046.
So then you get this number, and that number that you get is going to be the first number in the normal CDF.
Guys, I actually kind of understood that.
Okay, and this is because we're doing normal CDF for a normal model. Okay.
Is the first number 0.65?
What?
I did the math and got 0.65. Is that all right?
You did this
Yeah.
and got,
Is that not right?
0.65. I got it too.
I got.
that's interesting.
Am I wrong?
That's
Probably.
not what's on my paper, but that's doesn't necessarily mean that it's wrong.
What did you guys get?
0.65.
I got -6.
Oh.
0.33 minus 0.3. Did that whole thing. Answer divided by 0.046.
What'd you get?
Well, I got what y'all got, but that's not what was on my paper, so now I'm really confused. But anyways, I'm just confused as to how I got what I got. But anyways. Or last year they gave me false information.
They probably did.
So this is 0.652, right? That's what y'all got.
Yes.
So then we would do 1 times 10 to the 99th, and then 0 and 1 for mean and standard deviation,
Why is it 0 and 1 again? I forgot.
because it's a normal model.
It's only 0 and 1. Okay. Second. CDF.
Where did you get that first 0.33 from?
Because it wants 1/3 of the sample.
Okay.
So the sample standard deviation, which is Y bar, is 0.33.
I got 0.257.
I also got that.
Yay!
So based on that, okay, we want to draw a conclusion here. According to the normal model, the probability that more than 1/3 of students in this sample wear contacts is about 25.7%.
Okay, I actually don't hate this right now.
Honestly, these sections aren't, this particular section is not too
Wait, this
bad.
doesn't
It's pretty much
seem-
all like this.
Oh, so like, this doesn't seem like.
But
I'm
I will
not-
tell you this unit is chapters 18 through 22, so it's a lot of chapters that are going to be on that one
18,
test.
19, 20, 21, 20. Whoa.
So we'll probably do like 18, 19 on a quiz or 18, 19, 20 on a quiz, and then we'll do like 21 and 22 or 20 through 22 depending on, it kind of just depends on how much material there is in the sections, because like this is a short section.
I'm cold again.
Oh no. Are you weather bipolar again today?
Does everybody have all this before I switch to the next
Oh
one?
no. I really should have charged my calculator. We have a test today and I have to use it and mine's nearly dead.
Oops.
Oh no. I have a calculator
Also
charger.
very low.
You can always come get mine if you need it.
Can I use it though? Yeah, you can use the charger.
I'm just gonna pray that I know how to plug all these in.
Plug it. Do you have the? Is it just a USB? If you plug in the USB right here, I'm not joking. This thing charges insanely fast.
Go give it her.
Here, we'll swap calculators for class. Let's do that.
Thanks. So here, thank you. I was like, there's an
You
issue.
look like a frog for a minute.
I do this.
A frog or
Frog. I don't know why.
Where do you plug it in at? Oh, never mind. I found it.
Guys,
I don't have a fancy calculator.
what's another farm animal? We need to get a chicken.
The chickens were expensive, but I did
Really?
almost buy a chicken.
But look at them. They're so cute together. Got a pig and a cow.
How do you know if this thing's charging?
It
Oh.
turns red.
Yeah, it'll turn orange, and then it'll turn
Your finger's on it,
You have
not
to
the
turn it off.
calculator. The turn.
Oh.
And then you have to turn it off because it'll die. Because it just stays on.
He is so cute. I think I love Gerald.
Okay.
How do we know he's Gerald though?
Gucci.
Okay. There was another way, but not the most obvious way, is that he's missing part of his foot.
How is he already
Why is
missing a
this so
foot?
blurry? Okay, he had a nub on the bottom of his foot and it fell off. Don't fall
And then
off.
I think Rick has a brown dot.
Okay. I'm going to switch back to purple because it just seems more satisfying. A national study found that 44% of college students engage in binge drinking. 5 drinks at a sitting for men, 4 drinks for women.
That's bad.
That's insane. Okay. Use 68, 95, 99.7 rule to describe the sampling distribution model for the proportion of students in a randomly selected group of 200 college students who engage in binge drinking.
Okay, so first of all, the mean is 0.44.
Okay, so we need to do that stuff first. So I'm going to draw my over here. Oh, that's not in the center.
That was really bad. Oh, that was really bad. I will never understand how you do that. Nope. How do you make it even?
I got this. I looked up and I was doing the math over here.
Well, I am going to do the math, but I wanted to go ahead and draw this in so that it was there, and then now we can do the math. Okay,
Well,
so
I
you
got-
already told us what the mean was. I just didn't write it
I
yet.
got 0.035 for the standard deviation.
Okay, so mu of p hat was 0.44 because it says 44%, so we just keep that. Okay, standard deviation of p hat is the square root of 0.44 times 0.56 divided by 200. Okay, so success times failure divided by the total number of people in the sample. What did you say that's equal to, Brooke?
I got 0.035.
0.035.
Is that right?
That's what I got.
I also got that.
All right, so then as far as filling this in then, okay, our mean is here in the middle. So I want to list out my standard deviations that they are away.
0.475.
0.51.
I got 1.355. I got like 1 something.
And then I got
Is that right?
0.545.
Why did I have a 1?
Did you do 0.475 plus 0.035?
I have no clue.
So then on the other side it's 0.405.
Did anybody else get a 1?
No.
It's definitely Brooke's user error. It happens.
There's also user error on my paper then, because I have a 1 on my paper, but I know that's not right.
So
me and whoever did that made the same mistake.
Other direction. Did somebody say what those were?
Taryn.
405. One second. 37. And then 0.335.
My model looks so good this time. Like, actually, I'm so proud.
All right, so it wants us to use the rule.
Okay, I like this. This is fun. So, oh, you're already doing it. Uh-huh.
So 1 standard deviation is 68. 2 standard deviations is the 95. And 3 standard deviation is 99.7.
Boom. Loving it. Okay.
I'm loving
I'm in a really weird mood. I'm really sorry.
it. All right, so in reality, what they really want you to do is then to write exactly what's happening, but it's literally just what you've shown on your graph. So if you've shown your graph, I'm content with you having that, but I just want to explain what it
68%
means.
of the people drink between this and this. 95% of people drink between
Yes,
this.
exactly.
That's
So,
so stupid.
according to the normal model, about 68% of samples have size samples of the size 200 are expected to have 40.5% to 47.5% binge drinkers. About 95% of the samples of size 200 are expected to have 37% to 51% of binge drinkers, and so on and so forth. I am content, as long as you know what that means, with you just doing it this way.
Yeah, I
Okay,
definitely
with
know
just showing that.
because they would literally be like 68%.
Okay, if it says to explain like on like a quiz or test or something, just point to that and be like C graph. Okay. That's really all I'm looking for.
Wait, so if you were to explain it, it'd be like 68% of them engage in it.
68% of the that sample size have 40.5% to 47.5% binge drinkers,
Yeah.
basically.
I wonder if there's
And
a
then
way
you just keep going, and then
Yeah.
for the pig
that's
to never
so
land on the
annoying.
side.
All right, do you think the appropriate conditions have been met?
Yes.
Okay, so is it random?
Yes. Yes.
Okay, they randomly selected the 200
Yes.
students.
Right. Oh, no.
What?
Something was written too big. I had it on big
Success,
marker.
failure.
Yep.
So NP is equal to 200 times 0.44, which is equal to what?
I got it.
I'm going to go ahead and write NQ as 200 times 0.56.
And 88.
112 is the next one.
All right, and both of those are greater than or equal to 10. So
Yes.
check.
Random. And then the other thing was, what was the other thing?
10% condition.
Yeah, that's definitely right. Like, yeah.
200 students
Boom.
is greater than or equal to 10% of all college students.
So that's supposed to be less than?
Students nationally, so.
Sorry, yes. I don't know why I wrote that. Okay. So all conditions are met, so
So yes.
we can use a normal model of 0.44 and 0.035.
Oh! My cow landed standing up.
All right, so after hearing about the national results that 44% of students engage in binge drinking, a professor surveyed a random sample of 244 students at his college and found that 96 of them had been admitted to binge drinking in the past week. Should he be surprised at this result?
Yes.
Okay, well, we need to show mathematically, so.
But, like, yes. I would be sad.
Well,
Mathematically, bro.
I would be mathematically
not saying
sad.
he's not sad. It said, should he be surprised?
Yeah, I would be surprised. I'd be like, oh.
Okay, so mean is 44 or 0.44. Okay, the standard deviation though now changes because he's looking at 244 students instead of 200 students.
Why would you do that, buddy?
So the square root of 0.44 times 0.56 over 244.
Okay. I got .032. Really? Nice.
Okay, so this is what the results say that they should be, the mean and the standard deviation based on the data. Okay? But his sample mean, okay, y bar, is 96 divided by 244. Okay, because we had 96 binge drinkers out of the 244 surveyed. So what does that mean, actually?
I got .393.
Okay, 0.393.
You should be surprised.
So, then what we're going to do, okay, we're going to look at a z-score, but all we have to do is look at it, okay? The z-score is going to tell us how far
Oh, how far it is
from the mean, and then that'll tell us if it's unusual or, I guess, usual. I don't know.
Z equals
0.393 minus.
.44, right?
Wait. No.
No.
Yep.
0.
Yep, 0.44.
Over .032.
Because it's
Oh,
your
right.
sample mean minus the actual mean, or what the mean should be, over the standard deviation. Are you okay back there, Melcher? Is that a Charlie horse or something?
Owie.
Got negative 1.5.
So no. It's not to standard deviation over. Or I mean under, so it's fine.
Okay, so we can say that 39.3% is about 1.5 standard deviations below the mean, which is not terribly unusual.
That is sad.
Below is good, right?
I
Like
mean, yeah.
In this case,
Yeah.
it's good for it to be below.
Right, because that means that there's less than your
Yeah.
your average amount that are binge drinkers,
Yeah.
which I would classify as a good thing.
I mean, I would concur. That's bad.
Why does stats always deal with like
Why is it
alcohol
always
and
drugs and
Because
drinking?
it's an
cigarettes?
easy statistic to look
Yeah.
at.
It's true. Oh my word, we only have 2 left. Oh.
And it seems a bit more important than do they wear contacts?
If we have 2 left, does that mean we're getting homework today?
I'll probably let Monday be a work day for it. It's been a long week.
It has been a long week, and I don't want more homework because Miss Pang gave us all let's do Monday.
I'll let you have Monday to work on it. And that way you can ask questions if you have them, since
I also
this was a
finished
shorter
right now,
lesson.
I'm very proud of myself.
All right, we have all this. Almost.
Oh, I still also have to do all of Mrs. Patton's work.
I finished Miss Patton's work, but
And
I just
write all
had a
my
busy
notes.
weekend. Like I just don't have a free
And get
weekend.
ready for homecoming. Maybe by myself. I don't know yet. My mom said she might be able to come back around like 4. But we have to be there by 4:45. So I don't know.
We
if
gonna
that's
be a
gonna work.
worship practice, Maddie,
We do.
and then you set up.
So either A, she gets back earlier, or B, Joelle, help, I need you to do my hair. She said she'd be free. So. Or she told, I'm going to talk to my mom tonight and see if
I
I
wanna
can call
get-
her, but she said she'd do my hair if I needed it.
Thanks.
Unless I straighten it again. I just can't curl it myself. It doesn't work. I hold the curling iron the wrong way, and then like they're all going which way in that. It's not that way.
I'm ready. Go team.
All right. A restaurant owner anticipates serving about 180 people on a Friday evening and believes that about 20% of the patrons will order the chef's steak special.
I would.
That was a mouthful. How many of those meals should he plan on serving in order to be pretty sure of having enough steaks on hand to meet customer demand? Justify your answer, including an explanation of what pretty sure means to you.
What pretty sure means you're pretty, and you're sure.
means that you're pretty sure.
It means that you're almost certain.
You're fairly sure.
You suck.
You're close to positive it'll happen.
All right, so let's look at the conditions. Is it random?
Yes.
Are you sure?
No.
Okay. It's not random, but we don't technically have to be. The other option is that it can be a representative sample.
What
Okay.
does that mean?
Basically, it just means that it's like you don't really have control over who's coming in, right?
So it is kind of random.
In a sense, it is, but at the same time, it's like the people may be coming specifically for the special. Do you know what I mean? So it's just a representation.
No, are we saying that?
Yeah.
No, but.
No, but it's a representative sample. Because that's the other thing that it can be. If it's not random, but it's representative, like that is sufficient.
Ugh.
Okay, 10% condition. Yes or no?
I don't know, because how do we know how many people are going to go into this restaurant?
Well,
180 is actually kind of a lot on a Friday night.
I don't know. That's a lot.
but think about, though, like how many people, like let's just say this restaurant's in Newport News. How many people in Newport News could potentially show up?
Okay, no,
Everyone
yeah, it's
in
definitely
Newport
less than 10%.
Okay, yeah. So check because 180 is less than 10% of all potential. Okay, success failure.
Yeah.
N times P. Is that 0.2 times 180? I wrote them backwards.
36.
I was sad.
And then 0.8 of 180.
144.
That's definitely good.
144. Both of those are greater than or equal to 10. So success failures met.
Check.
So that means I can use what?
Normal model.
Okay, normal model. Okay, so we know the mean is 0.2. I don't yet know the standard deviation. So how do I find that?
You have to do the math.
You have to do square root of success times failure over n.
0.2 times 0.8 over 180.
Yep.
Oh. I'm already slanted now. Oh no.
Point two. No, I did 0.03. Sorry, I was gonna say 0.029 something, but it's 0.03.
Okay, so the normal model would be 0.2 and 0.03, okay, for me and standard deviation. So I want to look at,
Are we drawing it on this one? Oh no. Oh no.
but just, I'm actually kind of satisfied with that one. That one actually looks pretty good.
It's really good.
Why are you cool like that? You need to like be not cool for like 30 seconds.
All right, so the mean, okay, was 0.2. I'm only looking at how many he needs to make on like the high end, okay? So I only need to look at the right side. So adding 0.03
0.5.
be
Wait, I lied.
0.23.
That's not how you math.
Then adding another one, 0.26, and then a 3.
Because you're
2.9.
adding what, literally 0.03?
Yes.
Hey, I'm gonna be leaving like now. Are
Okay.
we doing anything different in class today?
I'm doing a little bit more with the examples that we like started on Wednesday and that you worked on yesterday. I'm doing the ones where like now you set them equal to 0 and solve.
Okay.
So it's really not any different. So I'll make sure I post it though.
Okay, thank you.
Have a good weekend. Don't really think he cares.
Well, I also think he's at lunch.
Okay. So where would we consider unusual?
3.
2 over 2.
Okay, over 2 standard
Over
deviations
2, I did
above.
that.
Okay, so 0.26 would be 2 standard deviations above, but that doesn't mean 0.26 stakes. We need to figure out, okay, this is saying 26% of the people that come in Okay, you're not going to have more than 26% of people ordering this special in theory. Okay, so what we need to do is 0.26 times 180.
Okay.
And I want to know how many steaks that is. That's going to give us the number of steaks that they need.
46.8, so 47.
Okay, so 47 steaks.
7 steaks. That's a lot
Okay.
of steaks.
That is 2 standard deviations above the mean.
No, Gerald.
Rip to Gerald. So it would be unusual to need more than that.
Unusual. Gotcha. Why am I crying?
What does that last word say?
It's supposed to say that.
What does it say?
It said line space AT. And I don't know why.
One at.
Oh, it's like one at.
Why am I? It's cool. I'm just literally like crying and I don't know why. It's just tears.
Because you're laying down.
I don't know if that's how it works, but I can't.
All right. In a there's a typo in this problem.
In a special promotion.
This number over here
What are groovy M&Ms?
is supposed to be 30%. Okay, in a special promotional bag of groovy M&Ms
I'm so scared.
are supposed to make up 30% of the candies in the bag. In a large bag of 250 M&Ms, what is the probability that we get at least 25% groovy candies?
Wait, why is it groovy?
I don't know.
What is the degree M&M?
I don't know.
Want a groovy M&M?
You do?
No, I want a groovy one.
I don't ever want to know.
I think it sounds a little bit like a bad thing.
It sounds.
Why is it bad? Oh.
Okay.
Sounds like a drug, bro.
Does sound like a drug.
All right, something to point out really quick, okay? It says that there's supposed to be 30% in a bag,
Yeah.
okay?
Yes.
So that is our mean, okay? But the probability that we get at least 25% groovy candies is our Y bar for the sample, which is 0.25.
Okay, that makes sense.
Okay.
Yeah, 'cause that's like the
So
special-
checking conditions, is it random?
Yeah.
Yes.
'Cause it's
10% condition.
Okay, hold on. Yes. It's less than the population of.
Of M&Ms, of groovy M&Ms.
What are groovy M&Ms?
I don't know what groovy M&Ms are. It's just a problem.
I want a groovy M&M. Oh no, I turned my bed old.
All right, success failure n times p. So
No, I lost
point-
all the words. No.
That's
No.
funny.
Oh, that sucks. Taylor, I need you to send me this page.
all right, so 0.3 times 250 for success. 0.3 times, or wait, sorry, 0.7 times 250
75.
I'm
for
just,
failure.
I'm just gonna wait for you to send it to me. Cause I ain't catching
What if
up.
I just don't? I'm joking, I will.
Then I would cry for Mrs. Quinn to send it to me.
No, Brooke, I send it too, I promise. I'll send it right when we're done. Or we should be more responsible.
Greater than or equal to
I
10.
didn't push the off button. It wasn't.
How do we know
That's a flaw in the design of the iPad.
condition is right?
Because
there's a
that's
lot
less
of
than
M&Ms.
10% of all M&Ms.
Like all M&Ms in the bag or all M&Ms in the world.
M&Ms in the world.
Okay. That's what I just.
Most of the time, you can assume that all these conditions are met. In your homework, there may be some that says, like, check to see if the conditions are met, like, specifically, and odds are at least one of them is going to not be.
Yeah. I was just making sure that the process is.
All right, so we can use a normal model for 0.3 and, we don't have the standard deviation yet. So the standard deviation of p hat is the square root of 0.3
Times 0.7.
times 0.7 over 250.
See, I can still do the work. I just lost it all.
I need to figure out where the test key is. So as soon as we're done with this problem, I can put it up there and we can start going over it.
I got some weird stuff.
How many are
wrong.
there total? 250?
You broke you on pillow?
Yes. Thank you.
0.029.
Alright, so 0.029.
Oh, this is actually so pleasant.
Right?
Why does it feel so soft?
I don't know, but it was like $5 at Target.
Seriously? Way to be cool.
Amazing. Alright, so I need to find the z-score. Okay? I want at least 25%, meaning I need more than that. Okay? So I'm still going to use normal CDF. Okay? But I need to find the z first.
I think it is 0.25 minus
So it's
0.30
actual
over
minus. Wait, I'm confused.
the standard deviation, which is 0.29. 0.29, my bad.
Wait, how do we know?
Because it's
So
y bar, it's like y hat minus y something.
It's like y bar minus mu over standard deviation.
Yeah, something like that.
Did you say it's negative?
Yeah, you are, Melcher. Kidding.
1.7 or negative 1.7.
Okay, negative 1.7. So, a rough sketch of this. Okay, means here. Mean is 30. Okay,
Still
but
it's better than
I need 0.25. I need greater than 0.25. So I want this area over here. Okay, again, it's just a rough sketch. Nothing super specific about it.
That's pretty.
So you're going to run the normal CDF of negative 1.7, then 1 times 10 to the 99, and then 0 and 1 again because it's a normal model.
I have a question. This is probably a dumb question, but so we're using normal CDF because it's a normal model, but we're also using 0 and 1 because it's a normal model. So what if I change that? Would it no longer be a normal model?
Well, you wouldn't get the same answer.
0.955.
We can use this because it's a normal model. Okay, so based on that, okay, our conclusion is that according to the normal model, probability of having at least 25% groovy M&Ms
Why?
is about, I'm going to have to find some of these and bring them in. It's freaking y'all out. It's about 95.5%.
I
They
wanna know.
are freaking me out.
Are they real?
Got it.
Choked on saliva.
Got it, guys. What is a groovy M